This ship is the largest aircraft carrier in the world. The name of the ship is USS Gerald R. Ford. It is quite an odd name for a ship. Basically, it is named after the 30th President of United States of America. The term USS stands for United States ship. Now, an aircraft carrier, it is basically an airport where you can land your aircraft or from where you can fly your aircraft. It is used for war purposes. As you can see, there are all fighter jets on this aircraft carrier. So an aircraft carrier is very important to a country, and most countries doesn't have one. This aircraft carrier took 8 years to build, and the length of this aircraft carrier is 304 meters from this end to this end. So it is quite a feat seeing this aircraft carrier in operation. Now, the problems which this aircraft carrier has to face in every day, in every second of its operation, is that of its engine velocity and of the water velocity, because it is traveling on water, it is not traveling on road, and water also moves. A road doesn't move. Just imagine you're traveling on a road in a car and the road starts to move. Obviously your car will sway left and right. For this thing to sway is very dangerous, because they would not want to crash into another ship, into an island, or move into some other territory. Let's take an example. Let's say that the velocity, not the speed, the velocity of the engine of this aircraft carrier, or the velocity of this aircraft carrier, is in this direction, straight forward, and that is 50 km per hour. And at the same time, there is water moving in this direction at a speed of 30 km per hour. Now it is very important to determine where will the aircraft carrier move, in which direction and with what velocity, and at what degree. The degree must be as accurate as possible. For this, let's try to use the triangle law of vector addition. As these two are vector, the velocity of water is a vector quantity, and so is the velocity of the aircraft carrier. To use the triangle law of vector addition, the first thing you need is a free body diagram. This is a free body diagram. It is the top view of the aircraft carrier, in which the speed of the engine and the speed of the velocity of the engine, not the speed, the velocity of the engine. Velocity is speed with the direction. So we have specified its direction to the left, hence it is velocity. Velocity of the engine and velocity of the water is given. Now we are to find the resultant velocity of the aircraft carrier. The first step is to set a scale. The scale I chose is 1 centimeter to 10 km per hour. This is all on your preference. You can set it as 1 centimeter equals to 20 km per hour, 1 centimeter equals to 50 km per hour. It all depends on your ease of usage. So the scale I set as 1 centimeter to 10 km per hour. Then I have to draw the two forces in such a manner that I have to join the head of one force with tail of another. So what I did is I moved this force to this point, the same angle with the same length with the same velocity to this point, see, and this force had an angle of 30 degrees with the ship. So obviously this is the horizontal line, this also will be horizontal line, this angle will also be 30 degrees, which I mentioned right here. Then when you draw the first two forces, which is the blue one and the red one, these two, then you have to complete the triangle. We have to draw the third side of the triangle, which is this. Now the third side of the triangle is the resultant of the two forces, and it goes in such a manner that it joins the tail of one of the force and its head. This is the head. The head joins the head of the other force. This is the head, this is the tail. This is also called head to tail method or tip to tail method. Tip tip to tail method or head to tail method. Head is also called the tip, right? The resultant goes in the opposite direction. The head of one force joins the tail of the other force, but the resultant goes in the opposite direction. The tail of the resultant joins the tail of one of the force, and the head of the resultant joins the head of the other force. Then you have to measure the length of the resultant. By measuring the length of the resultant, you'll get the resultant vector or the resultant magnitude of the two vector quantities. So the length in this case is 77.74 centimeter, which is equivalent to 77.4 km per hour, as 1 centimeter was what? 10 km per hour. Then you have to measure the angle, because obviously you need the angle. Angle is the direction. Without direction, a vector quantity is useless. This is the angle theta. Now we try to measure the angle with the horizontal. This is my horizontal, or you can say this is my reference line. So this was my horizontal, right? Hence this will be my horizontal. These two are parallel lines. This angle will be equal to this angle, as the velocity of the engine was directly on horizontal. So I have to find this angle. I'll measure it by using a protractor. This angle, by measuring it, is 11.1 degrees. Hence the resultant velocity of the ship is 77.4 km at an angle of 11.1 degrees from the horizontal. So this is how the ship will go. When the ship is moving forward with the velocity of 50 km per hour and water crashes in at 30 degrees with a magnitude of 30 km per hour, the ship will move in this direction at an angle of 11.1 degrees below horizontal, this angle right here, below horizontal, at a velocity of 77.4 km per hour. So as you can see that I have moved apart these three forces from the triangle. You can move them in however manner you want, but the direction should remain the same. For example, if a force is in this direction, you can move it downwards, but it must be in this direction of the same length. You can move it to the right. It must be in this direction of the same length. So that is how you use the triangle law of vector addition. And this is only for vectors who are not parallel to each other. When the vectors are parallel to each other, just add them up or subtract them up. When the vectors are not parallel, you use the parallelogram of method or the triangle law method.